Okay, professor, here's our DHT example of Nathaniel Guzman and my group. Here's the circuit with the sensor and the Arduino right here. And right here I have the code. Basically, to make it look like this, exactly the same way the output is formatted on the assignment tab, on the assignment PDF. We had to modify the code a little bit. This is the example code for reading the temperature. The code that was on the examples on the library of the DHT non-blocking. So in order for that output to show, we had to first of all do some formatting of the temperature and humidity here. That way we get the same letters and the same phrases on it. And the complicated part was to get the raw data. So the first thing we notice is that right here, this is part of this is an object of a class. So knowing that, we can go to the library, which I have it right here, the H file, the CPP file, and we can see the class and the object that that function is part of. So in this case, this is a class. We see that one of the elements of the class was data. Originally, this element was in the private section. That means that we couldn't access it outside the library. So I cut it off and I put it here on the public section. That way we have access to that data. We're doing that because we also wanted to get the whole raw data with the checksum and everything. The library takes care of the reading of the data with the function right here, read data. So we don't have to worry about it. But and it loads that those bytes in the data array. So now, if we go here, what we have to do, okay, what is it? Okay, is use this case we're using the word byte to convert this data array element into a byte variable. And we're storing that on the var variable. I have a variable here to do a count, and then I have a for loop of 8 bits, sorry. We're doing a serial print. We're using the function bRead in order to read each bit of the byte one by one, and every 4 bits we are inserting a space right here. Done that way, we can get the proper raw data, the whole 5 groups of 4 bits. Okay, sorry, the whole 5 bytes, I'm sorry. Which is the first byte is for humidity on the integer side, the second byte is for humidity decimal side, and for temperature is the other 2, and the last byte, number 5, is the sum of each, so you can get a checksum, and that's the way it works. It's just a minor modification of the library that was required. To avoid this, what we can actually do too is to compare the temperature and the humidity values straight to a byte, but again, this way we have the full raw data.